Good morning, everyone, and thank you for being here today. I'm Dr. S.K. Singh, and I'm excited to present to you on the topic of source of contamination, specifically focusing on cleanroom garment system failures. Today, we'll explore how these failures can impact contamination control, what causes them, and ways to prevent such issues. So, let's get started and take a closer look at this important subject. Let's start with the basics. Cleanrooms are absolutely essential for contamination control in pharmaceutical manufacturing. They provide a controlled environment that helps ensure the safety and efficacy of the products we produce. Now, one of the key points to remember is that personnel are actually the largest source of contamination in these settings. Despite all the technology and procedures we have, human beings can inadvertently introduce particles, microbes, or other contaminants. This is where cleanroom garments come into play. They act as the primary barrier between the personnel and the product. Properly designed and maintained garments are crucial because they help prevent contamination from reaching the products. But it's not just about wearing the right gear. Failures in the garment systems, whether through wear and tear, improper use, or inadequate maintenance, can lead to serious issues. These failures can result in product contamination, which compromises safety and efficacy. They can also cause regulatory noncompliance, putting the manufacturing facility at risk of sanctions or product recalls. Ultimately, if contamination is detected late or if systems fail, it can lead to batch rejection, wasting resources, and delaying product release. Understanding these points helps us see how vital proper garment management and contamination control are in maintaining the integrity of our manufacturing processes and ensuring patient safety. So, what exactly is a cleanroom garment system? Well, it's a comprehensive setup that includes all the key clothing components needed to maintain a controlled environment. This typically involves coveralls, hoods, gloves, masks, and boots. Each piece plays a vital role in ensuring the cleanliness of the space. The main purpose of these garments is twofold. First, to contain particles shed by the personnel wearing them, and second, to prevent any outside contaminants from entering the cleanroom. It's all about creating a barrier that keeps the environment as pristine as possible. When we talk about the materials used, you'll notice they are often polyester, PTFE, or non-shedding fabrics. These materials are specifically chosen because they help minimize particle generation and are durable enough for repeated use in sterile environments. Overall, a well-designed cleanroom garment system is essential for maintaining product integrity and ensuring safety in environments where even tiny particles can cause big issues. Now, let's take a closer look at the different types of garment system failures. One common issue is material degradation, which can happen over time due to exposure to sterilization processes or environmental factors. This degradation can weaken the fabric and compromise its protective barrier. Improper gowning practices are also a significant concern. Even the best garments won't be effective if not donned correctly. Garment damage, such as tears or holes, can occur during handling or use, creating potential contamination pathways. Additionally, inadequate laundering or sterilization processes may leave residual contaminants or damage the garment, reducing its effectiveness. Poor garment design or an ill-fitting gown can lead to gaps or discomfort, which might also increase contamination risk. Understanding these failure modes is crucial because, in pharmaceutical manufacturing, garments play a vital role in maintaining aseptic and sterile conditions. They are required to meet strict regulatory expectations set by agencies like the FDA, EMA, and WHO. These regulations are in place to ensure that the products we produce remain sterile and safe for patients. Ultimately, proper garment management directly supports product sterility and patient safety, which are the foundations of quality in pharma manufacturing. Let's talk about material degradation. Over time, repeated washing and sterilization can really weaken fabrics. This isn't just about appearance, it actually affects the material's fundamental properties. For example, it can cause a loss of barrier integrity, meaning the fabric becomes less effective at preventing particles or fluids from passing through. It can also diminish electrostatic properties, which are critical for certain protective functions. Take microfiber, for instance. When it breaks down due to this wear and tear, it can lead to particle release. And this is important because the result is increased particle shedding into the environment, which could pose contamination risks. So, understanding how these processes weaken materials helps us appreciate the importance of proper maintenance and material choice in our overall safety and infection control strategies. Now, let's talk about improper gowning practices, which can be a significant source of contamination in sterile environments. One common issue is incorrect donning or doffing techniques. If not done properly, it can compromise the sterile barrier. A typical mistake is touching outer surfaces of gloves or gowns, which can transfer microbes directly to sterile areas. Another frequent error is improper glove sealing. If the gloves don't seal tightly around the wrists, it creates exposed skin. For example, exposed skin at the wrist can lead to microbial contamination because it provides a pathway for germs to enter the sterile field. This is a major cause of human-induced contamination, and it's something we want to avoid at all costs. Overall, proper gowning techniques are essential to maintain sterility and protect patients from infection. Small mistakes in this process can have big consequences, so vigilance and attention to detail are key. Let's talk about poor garment fit and design. When clothing doesn't fit properly, it can create gaps that allow particles to escape or enter, which is a major concern in controlled environments. Design flaws such as loose cuffs or poorly functioning closures like zippers and snaps can also compromise the protective barrier. For example, air leakage pathways around the neck or wrists happen when the fit isn't snug, leading to potential particle escape and ingress. Next, physical damage to garments is another critical issue. Tears, punctures, or seam failures can develop over time, often due to mechanical stress or contact with sharp equipment edges. Even small tears, like in a coverall, might seem insignificant but can be critical because they can allow particles to escape without being immediately visible. Recognizing these vulnerabilities is essential to maintaining the integrity of protective clothing in sensitive environments. Let's talk about laundering and sterilization failures. When cleaning isn't effective, it can leave residual contaminants behind. These remnants can be a breeding ground for microbes, which might survive the process altogether. The key causes of these failures often include overloading washing systems, which prevents thorough cleaning, and using improper sterilization cycles that don't fully eliminate contaminants. For example, if garments are not properly cleaned, endotoxins can remain on the fabric. These endotoxins can cause serious issues if they're introduced into a sterile environment or patient, highlighting how crucial proper laundering and sterilization practices are in maintaining safety and quality. Let's take a closer look at the contamination mechanisms involved in this process. First, we have particle generation. One of the main sources here is skin flakes, which we shed at a rate of about 1 million particles per day per person. These tiny skin flakes can carry microbes and are a significant source of contamination. Next, microbial shedding occurs when bacteria attach themselves to these skin particles. This means that bacteria are often traveling along with the flakes we shed naturally, which can pose a risk if they contaminate sterile environments. The third component is transport. Contaminants are moved around primarily through airflow. Think of the air currents in a room or a clean room, and through operator motion, like walking, reaching, or any movement we make that stirs up particles. By understanding these mechanisms, we can better appreciate how contamination spreads and what control measures might be most effective in reducing it. This ties back to the overall theme of maintaining a contaminant-free environment. Let's look at a real-world example from sterile injectable manufacturing. The scenario here involves an increase in environmental monitoring counts, which raised some red flags. Now, the root cause was identified as degraded garments that had been reused too many times. This degradation compromised the barrier protection, leading to contamination risks. As a result, the batch was rejected, highlighting the importance of proper garment management. Following this, an investigation was carried out to understand exactly what went wrong, and a corrective and preventive action, or CAPA, was implemented to address the issue. This example underscores how critical it is to monitor environmental conditions closely and maintain strict controls over gowning procedures. It ties back to our overall theme of quality assurance and the continuous improvement needed to prevent contamination and ensure patient safety. Let's now look at detection and monitoring, which are essential components of maintaining a controlled environment. First, environmental monitoring involves tracking particle counts to measure the level of airborne particles, which helps us assess cleanliness and identify potential contamination risks. Microbial air sampling is another critical aspect, where we sample the air to detect any microbial presence that could compromise product safety. Moving on to garment inspection, visual checks are performed to ensure clothing is intact and free from contamination. Integrity testing further verifies that garments and barriers are functioning properly, providing an additional layer of protection. Finally, trend analysis plays a vital role. It helps us identify recurring failures over time. Recognizing these patterns allows us to implement targeted improvements, ultimately supporting our overall goal of consistent quality and safety. All these monitoring methods work together to give us a comprehensive picture of the environment, ensuring we maintain the highest standards throughout our processes. Let's talk about prevention and control strategies, which are essential for maintaining a sterile and safe environment. First, garment lifecycle management is crucial. By carefully tracking and managing how long we use each gown or garment, we can prevent wear and tear that might compromise sterility. Next, having defined reuse limits helps us ensure that garments are not reused beyond their safe lifespan, reducing the risk of contamination. Validated laundering processes are also key. By following proven procedures, we guarantee that all garments are properly cleaned and disinfected. Training programs play a vital role. They ensure everyone understands and consistently applies the correct gowning techniques and behavior in the cleanroom. Proper gowning techniques are fundamental. They help prevent contamination from the moment someone enters the controlled environment. Routine inspection is another critical point. Regular checks allow us to catch potential issues early, whether it's damage to garments or lapses in protocol. Using high-quality materials for garments and other supplies also makes a big difference. They're more durable and less likely to shed particles. Finally, maintaining discipline in cleanroom behavior is essential. Consistent discipline ensures that everyone adheres to protocols, which is the backbone of effective prevention and control. All these strategies together create a comprehensive approach, helping us uphold the integrity of our cleanroom environment and ensure safety at every stage. So, in conclusion, it's important to recognize that cleanroom garment failures are a critical source of contamination. Even though these failures can often be subtle and not immediately obvious, their impact can be quite high, potentially compromising product quality and patient safety. To effectively manage this risk, we need robust systems in place that can detect and prevent failures. Continuous monitoring is also essential, so we can catch issues early and maintain a consistent level of cleanliness. Additionally, personnel discipline plays a key role. Everyone must understand and adhere to proper protocols. Ultimately, these measures are vital not just for regulatory compliance, but also for ensuring the highest standards of product quality and patient safety. This highlights how interconnected our systems, monitoring, and personnel are in maintaining a truly clean and safe environment. For further support, please don't hesitate to contact us. We're here to help you with any questions or additional information you may need. Thank you so much for your time and attention today. We appreciate your interest and look forward to assisting you further.